we're going to take a quick look at. I want you to start by drawing boxes just like what you see up here on the screen. Give yourself a little space from box to box, but I want you to configure it the same as what you see up here on the screen. And again, this does not need to be a Rembrandt, just some quick boxes is fine. All right, so first of all, what do these words have to do with these boxes? All right.
Are they the different types of numbers?
Okay, so these are the different sets of numbers that we often talk about when we're talking about types of numbers, categories of numbers, sets of numbers. Okay, so what do the boxes have to do with those sets? Explain why this configuration has some relationship with those words, with those sets of numbers. What do you think?
Like, for example, a real number is also, it could also be a whole number. So like one number can be part of different categories. So it'd be like faced differently.
Okay. Anybody else want to add to that? So which one of these should I label this first box as? What's the most restrictive set of numbers that you can think of? Natural? Which one's more restrictive, natural or whole? Natural, okay. So if that one's natural, then what's the next box outside of that? That's the whole numbers. Okay, then what? What's my next box? Integers. Okay, next box outside of that? The rationals. Okay, so what's this sad little box over here all by itself? The irrationals. Kind of its own little animal. So where do I put real? Outside the whole thing. This entire box represents what we call real numbers. Not yet. Okay? So, imaginary numbers go beyond this box. And when we get to, I don't remember which chapter it is, but we will get to those and we'll add on that box later. Right now, we're just interested in the real numbers. So these are the different categories within the real numbers. So now what I want you to do is, if you haven't already, label your boxes the same way. And then I want you to take all of these numbers you see around the outside and put them in the box you think they should go in. We want to put them in the most restrictive box we can. Okay? So even though everything's well, almost everything. A lot of stuff is rational. If it's also an integer, integer is more restrictive. So you'd want it in the integer box, not necessarily the rational box. Make sense? Okay, try it. Go. All right, if you're not quite done, you can fill them in as we go, but let's go ahead and take a look at this. So I'm going to start here. I'm going to go this way around. All right? So I want you to basically just kind of shout out where you think it should go. So let's start with -3. Where should -3 go? Integers. Whoops. Oh, go away. Integers. Okay? 2/3. Rational. Good. Square root of 5. Irrational. What's the difference between rational and irrational? Okay, so irrational is when it could be written as a fraction. Doesn't mean it necessarily is, but it could be. Whereas irrational is when it can't be. So another way we talk about it is in terms of rationals have decimals that are terminating or repeating, but an irrational would end up being a decimal that doesn't do either one of those. It doesn't end, it doesn't repeat, it just keeps going on and on with this just mess of numbers. Okay? So if you actually put square root of 5 in a calculator, that's what you would see as far as your screen would hold. How about a -1/4?
Rational.
Rational, good. What do you suppose the most common mistake with -1/4 is? Where would they put? Integers. Because we sometimes think, oh, negative, integer. But remember, integers are only whole numbers and their opposites. So anything that's a fraction or a decimal that's negative doesn't go in the integers, it goes in the rationals. Okay, good. -39. That's an integer. Put that one over there. Pi. Irrational. Good. Negative square root of 16. Integers. Yeah. Why is it an integer and not an irrational?
-4.
Yeah, because when you simplify it, it becomes -4, which is an integer. Sorry. Yeah, as I was saying that, I'm like, wait, I put that in the wrong box. All right, so negative square root of 16 should be in the integer box. 3.17. Rational. It's a terminating decimal, so it's going to go in the rationals. 6. Natural. Finally, one of the counting numbers. This is also sometimes called the counting. category. Okay, natural or counting, same thing. Negative square root of 10. Irrational. 0. Whole. Remember, that's the difference between natural and whole, is that 0. Okay? 0.363636 ...
Irrational.
Which one? Rational, because it's repeating. It goes on forever, but there's a set of numbers that keeps repeating itself, so that makes it rational. We could somehow change that back into a fraction. Okay, negative 27. Integers. 2.
Natural.
Natural. E. Remember E?
It's that special number.
It's that special number, that weird thing in the logs and exponents. And it's irrational. Yep. That's why we use the E, because it's this long, never-ending, never-repeating number. So we use the symbol E as a way to represent it, just like we use the symbol pi to represent that number. Okay? 15.2.
Rational.
Rational. Negative 1,904. Integer. 4/5. Rational. Negative 0.2. Rational. 0.75. Rational. 12. Natural. Okay, so that's how your number should have gone. If you didn't get some of those, make sure you fix it. Now, what I found in my experience was, in high school, this is one of those things that it's kind of just nice to know, right? Like, it's kind of nice to know which types of numbers there are, and sometimes you get asked questions specifically about a certain type of number. But what I found was in college is where you really need to know this, because you start getting into those upper level college classes, and a lot of times things that you're trying to do only happen with a particular set of numbers. Like, you can only use the integers for a particular thing, or you can only use the whole numbers for a particular thing. And so you have to know what kind of numbers you're dealing with, because you're only allowed to use a certain set. So even though you may feel sometimes like, yeah, this is all fine and good, Mrs. Gordon, but when do we ever use this? I found in college level, that's where you actually have to know these categories. So it's good just to remind ourselves each year as to what those are. Oh, come on. I lost the thingy. Where does it want to go? Okay, I don't know. I don't know how else to make that go. I guess I have to come over here. Sorry, I'm kind of new to Smartboard, so you're going to see me every now and then kind of being like, oh, I don't know how to make this work. We'll figure it out. Did I lose my thing? I did. That's the problem. There we go. Okay, properties. This is another one that you go through every year at the beginning of the year, and then you always go away going, are we ever going to use this? Properties are one of those things that you use subconsciously. Like, you don't realize when you're doing something that the reason you can do that is because of properties that allow it. Because without properties, the only rule we have about doing problems is order of operations. And order of operations is very specific. It's parentheses or grouping symbols, then it's exponents, then it's multiplying and dividing from left to right if you have more than one, and then it's adding and subtracting from left to right if you have more than one. That's it. End of story. Order of operations. So if you didn't have these properties, that is all you would be allowed to do. And the properties kind of say, yeah, but there's a shortcut, and it works every time, so it's okay. And you've gotten to a point where, because you know the shortcuts, you do them without thinking about them. But you've got to understand that the reason why you can do some of them is because there's a property that allows it. So it's another one of those things that's just good to refresh our memory at the beginning of every year. Okay, so can someone give me an example of any one of these 6? Pick the one you like, give me an example of it. Yes.
Distributive, so A parentheses B plus C equals AB plus AC.
Agree with that? Is that what distributive looks like? Is that the only way distributive can look like? What else could we do?
We can like reverse it.
Okay, we have to keep in mind that these properties are not one directional. So I can go this way, I can start with something that looks like this and turn it into this, or I can start with something that looks like this and turn it into this. Okay, is there any other variation I can do on that that would still be considered distributive property? Does it only work with addition? We can also do subtraction. Okay? Someone else, pick another one. What do you like? I don't care if it's numbers, letters, just give me an example. Oh, come on. What's the commutative property? Give me an example of the commutative property. You need Sophie to help you? Yes, I'm asking you. Do you have an example of the commutative property? Not sure? Need Sophie to help you out? She's got her hand up. She's willing to help you out. Yes? Okay, Sophie, help him out. Yes.
When you have like 7 minus 2 plus 6, you can make the minus, I forgot my numbers now, but the middle one negative and switch them.
Okay, you're taking it a step, I think, farther than what we're really looking for. You're getting into more of like how I can use the commutative property to make my life easier. Okay, but let's just keep it really simple. What is an example of just the commutative property?
Is it A plus B equals B plus A?
Yes. Think of the word commute. Anyone know what the word commute means outside of math?
Go back and forth.
To go back and forth. If someone commutes for their job, it usually means that they live outside of the city and maybe they commute into the city, or they live in the US and they commute to Shanghai and work for 3 weeks and then commute back. Commute means going back and forth. So that's what happens in the commutative property. You are switching your numbers or your variables back and forth, right? Moving them back and forth. That's the commutative property. Does it only work with addition? What else does it work with? Multiplication. Yep. Okay, so that's commutative. How about associative?
I think it's A plus parentheses B plus C equals parentheses A plus A.
Say what it equals to again.
Parentheses A plus B parentheses plus C.
Okay, so again, outside of math, if I said that Katrina associates with Henry, what does that mean? They interact. What did you say here? So they interact. They are together. They group, right? So that's what the associative property is about. How can I put the numbers or the variables together? And what this is saying is it doesn't matter when I'm doing all addition whether I decide to add the B and C first and then do A, or whether I decide to do the A and B first and then do C. So it's all about how we're grouping it, associating those things together. Does that only work for addition? What's it also work for? Multiplication. So with most of these properties, They work for addition and multiplication. Okay? So what happens when we have subtraction? That kind of gets back to what Sophie was talking about. We also know we have this property, and it's not necessarily one of these per se, but we have this property that says when I'm subtracting something, I can also make it into adding the negative, adding the opposite. So then that turns it into addition, and then the properties work. Okay? Identity.
A is equal to A.
Close.
Anything
Was it
times
8
one.
times 1 equals 8?
Okay, anything times 1
Oh.
equals
Oh.
itself, right? There we go. How about for addition? What's the identity property for addition?
Plus 0.
Anything plus 0 equals itself. So the identity is what we can do to get the same thing back. So with addition, it's adding 0. With multiplication, it's multiplying by 1. Now, there's a certain sense of, well, duh, to that. Like, we needed a property to tell us that. But in a sense, yes, because now we can say, all right, so what if I group things in a way that'll give me a 0, so then I know when I add it to the A, I'm just going to get A. Or what if I group things in a way that are going to multiply to give me 1, so then when I multiply it to that other A, I'm just going to get A. So it's when we start using things in combination that we're like, that's why this makes it easier. If I group these two together first, that's going to end up being a 0, so then I know I'm just left with that. Okay? Inverse. Anybody know inverse for addition?
Addition, I'm not sure.
Okay, what about multiplication?
A multiplied by minus 1 equals minus 3.
Not quite. It does make sense, right? Inverse a lot of times means like opposite, and so it seems like minus, but no, that's not quite it.
1 divided by A.
You're close. 1 divided by A.
Is equal to 1 divided by
Not quite. But you're on the right track. We want to use the reciprocal. So what happens if I take something, multiply it by the reciprocal, we get 1.
Oh.
What happens if I take something, what do you suppose I want to add to it?
Negative.
The negative, yep, the opposite. And what will that give me? 0. So the inverse property is sort of that undo property. How do I undo what I have? So if I start with A and I want to add, I have to add the opposite to undo it and get 0. If I'm multiplying, I have to multiply by the reciprocal to end up with 1. All right, the tough one, at least in my opinion, I think this is the toughest one. And maybe it's because it's so obvious. Maybe it's because it's the one we don't talk about very much. But closure, I always have a tough time getting my head around. Closure, anybody know it? Don't want to steal anybody's thunder. Okay, closure is the one that says, basically, if I'm going to perform operations with real numbers, the results I get have to be real numbers. So if you have a closure property for any set of numbers, what it means is if I'm going to perform operations with those types of numbers, the only kinds of answers I can get are those types of numbers. So for example, integers have closure because if I add or subtract or multiply or divide with just integer, oh no, I take that back. Maybe it's just for adding and multiplying. Because if you divide integers, you may not necessarily get an integer, right? Change you both for a second. I have to check my thinking on this for a second. Properties, what are properties? Properties. Let's see, first lesson. Let's see what they say about closure. Closure. No, it's also just for addition and multiplication. No division. So integers would have closure in addition and in multiplication, because if I add two integers together, I only get an integer. If I multiply two integers together, I can only get an integer. Okay? Real numbers have closure, because if I add two real numbers together, I only get some kind of real number. If I multiply two real numbers together, I only get some kind of real number. Okay? So that's what the closure is. Oh. So if A and B start out as real numbers in the first place, then adding them together or multiplying them together have to give me a real number as a result. Okay? All right. We've kind of run out of time here. We're about to wrap up here in just a few minutes. So here's what we're going to do. You have an assignment that's going to take you through some of the types of problems on Chapter 1 that we would expect you to know how to do. Let me get you up here. So on Canvas, if you go to your Honors Algebra 2 class, my homepage is always the modules. Okay, so the modules are going to be organized by the chapters we're going through, and then what's under those will be in chronological order, and pretty much anything that you're going to need access to, you're going to be able to access from this page as we get going. So for right now, we are working with Chapter 1 through 3 review, and you have a Chapter 1 practice here. And when you open that up and scroll down a little bit, you see that it's basically from the Chapter 1 review. So you're going to be doing 7 through 47 on. I want you to do those for homework for Monday. And anything you have a major question about that you do not know how to do, you looked back in the lessons, you couldn't figure it out, we're going to have a little bit of time on Monday that we can address some of those questions before we take the actual pretest. Okay, because the pretest is not going to take the full period. So if there's anything that you're just totally lost on, make sure that you make a note of it so you can ask about it when you come back on Monday. The answers to these, since you're just doing the odds, should be in the back of the book, so you should be able to check yourself as you go to see if you're getting the right answer or not. Okay, and we can address a few questions then Monday before we take the actual pretest. But the pretest will be over all of 1, 2, and 3. Okay, and it's just a pretest, so if there's some things you don't know, that's okay. That's what we need to know, is that there's certain things we have to make sure we address. Okay? All right, go ahead and get packed up. We'll see you guys on Monday.
Wow.